to explain the covalent bond. Let us try to understand that also. See, you can see here in the covalent bond, you can take up the example here specially, that is Cl2 formation. Okay, so how you are going to explain this formation? This is very important. Suppose you have chlorine, right? So chlorine is having atomic number of 17. Okay, so it is going to actually have 2, 8 and 7 configuration, right? So what happens? You will put one chlorine like this. Okay, there are 7 valence electrons, so you will indicate it with the help of like this dots. So you have 1, 2, 3, 4, 5, 6, 7. So this is the thing. Okay, now next is another chlorine molecule that will come. So we will draw like this. The another chlorine molecule, again there is a valence 7 electrons, so you will show it by star. Okay, like this. So this is actually another pair of electron in order to just differentiate. So now what will happen? This electron, okay, they will combine together to form the pair that will be shared between these two chlorine atoms. Let us write the chemical reaction. Now what happens here? You will write here. Okay, so you have here the same thing is just repeated here. Simple thing is that you have to show the sharing of electrons. That is very important. So you can see here very clearly electron pair is shared, okay, here between two chlorine atoms. The rest things that will remain as it is. Okay, so this is very important. So as there is a single pair of electron is shared between two chlorine atoms, so what happens? This will form a single bond between two chlorine atoms. So this will result in formation of Cl2 molecule. Okay, so this is the example of the covalent bond. Cl2 formation is the example of the covalent bond. Okay, now let us try to take the another example, that is formation of O2 molecule. You have covalent bond example. Now we will be taking O2 molecule. So what you will do here? Okay, in O2 molecule basically you have oxygen with the atomic number of the 8. In that you are supposed to show 2, 6. This is the configuration. So what you will do now? You will show the electron pair 1, 2, 3, 4, 5, 6. Okay, this is the one oxygen plus another oxygen. Okay, in order to differentiate we will put the cross. So we will write here like this. Okay, after this what we will do? O2 is formed. How it is formed? We have oxygen like this, we have oxygen like this. Okay, you can see very clearly this pair and this pair, that you are going to write it here. Okay, like this. So this is shown, two pairs of the electrons are shared between two oxygen atoms. Rest things remains similar. So as two pairs are shared between two oxygen atoms, so there is formation of O double bond O. Okay, so this is the example of the covalent bond again. So you can take the formation of Cl2 molecule, you can take the formation of the O2 molecule as well in order to explain the covalent bond formation. Clear? Okay, now what we will take up the next? We will take up the characteristics of the covalent bond. Characteristics of the covalent bond: they exist in liquid and gaseous state. Okay, they are insoluble in water, they are soluble in organic solvent, they are poor conductor of electricity in molten state, they have low melting point and boiling point. So this completes your 5 mark of the question. So what point we have covered? We have covered the definition, we have covered the chemical reaction, and we have covered the characteristics also. Okay, so these things are there. Let us proceed ahead. The question 5b, that consists of write a short note on chlorination of water. So what we are doing is we are passing the chlorine gas in water. So we have written chlorine gas is directly passed into water. It reacts with water to form hypochlorous acid and nascent oxygen. Both are powerful germicides. Now what happens when you are passing your chlorine in water? It is going to form hypochlorous acid and nascent oxygen, and they both are powerful germicides. Let us try to understand the next important question that is asked in the GTU in this format. Question 6a, what is paint? Explain its constituent and function. Now this question carries 5 marks. You can see very clearly that they have asked for the function of paint, that is the role of paint. They have asked for the constituents of paint, and they have asked for what is paint. Okay, so this thing again you can see question 6b, that is fire point, saponification number, ionization energy, electron affinity, orbital. These 5 definitions are asked in question 6b. So what happens in 6b? There are 5 definitions. Each definition carries 1 mark. The C part is again explain control of corrosion by modification of design and choice of material. So this is the thing. Now question 6a consists of what is paint? Explain its constituent and function. See, paint is, you can first write down the definition. Paint is mechanical dispersion mixture of one or more pigment in vehicle. Okay, so that is paint. Constituents of paint, what are the components of which the paint is made? So there are pigments, vehicle or drying oil, thinners, dryers, fillers, plasticizers. These all are the components of which your paint is made. Okay, so paint, we have covered the definition, we have covered the constituent. Now what is the next thing that is required? The function of paint. What is the role of paint? So that we are going to highlight. Function of paint. Paint protects surfaces like iron and wood from wear and tear. Paint protects surface from insect, moisture and fungus. Paint prevents corrosion. Paint reflects heat and light. It gives good appearance to the surface. So this is the role, or you can say the function of the paint in the routine life. Okay, so this is the entire solution to the question what is paint, what is constituent and what is function. When we are completing these 3 parts, then our entire question is now over. So it is very essential that you start up with the definition, you will explain the role, you will explain the composition. So this will complete your entire 5 marks answer. Let us proceed to the next question of the definitions. The first definition that was asked here is question 6b, that is fire point. Now if possible from your side, you can always take up the definition with the example if it is possible. Okay, here there is no case. So in the fire point you can see here minimum temperature at which oil gives enough vapors which catches fire and burn continuously at least for 5 seconds when flame is applied to it. So what is fire point? It is the minimum temperature at which oil gives enough vapors which catches fires and burn continuously at least for 5 seconds when flame is applied to it. So this is actually your fire point. Next you can see the definition of the saponification number. What is saponification number? It is number in milligrams of KOH required to saponify fatty material present in 1 gram of oil. Okay, so this one has to remember. Saponification number actually deals with number in milligrams of KOH required to saponify fatty material present in 1 gram of the oil. So this is saponification number. That is again the definition which is very clear in the mind. Make sure that you write the definition with the proper words. Say here milligrams is emphasized, KOH, that is potassium hydroxide, is emphasized and present in 1 gram only, 1 gram of the oil. So make sure that you are writing all the terms in the very correct way. Okay, this is also very important. You cannot put NaOH in presence of the KOH or something different. So this all terms are very important when you are writing the answers. Next question, that is next definition, you can see here ionization energy. Very important definition that is always asked. Minimum amount of energy required to remove most loosely bound electron from an isolated gaseous atom in its ground state is called ionization energy. Okay, so what happens here? How much minimum energy you are supplying to remove most loosely bound electron from isolated gaseous atom, that is your ionization energy. The unit of ionization energy is kilocalorie per mole. Okay, so that is the unit of ionization energy. So this one has to remember. Very important definitions, each definition carries 1 mark. If you are attempting all the definition in a correct way with the scientific words, then your all the marks are ensured. These 5 questions you will get all it correct done and 5 marks are encashed automatically. So in the book whatever definitions are given, it is from your side. You have to learn the definition as it is without manipulating it. Okay, so take care when you are writing the definitions. Use proper scientific word, use the proper terminology that is given. Do not replace any word by your own words. That is most important thing that you have to remember. The next definition, that is electron affinity. What is electron affinity? The amount of energy released when an electron is added to an isolated gaseous atom is called electron affinity. So what does it mean? Electron affinity is nothing but just the opposite of ionization energy. If you see here the comparison, you can just see the next, that was amount of energy required to remove most loosely bound electron, and here what is the comparison? Amount of energy released when an electron is added to an isolated gaseous atom. Okay, so that things you have to remember. That is our electron affinity. Okay, the next thing that we are supposed to see here is orbital. The most important concept which always gets confused with the orbit and orbital concept. So here the definition asked in the paper is orbital. So what we are supposed to do is, we are supposed to put the definition in a very correct order. So what is orbital? It is defined as 3-dimensional space around the nucleus in which probability of finding electron with certain energy is maximum. Okay, so orbital is nothing but 3-dimensional space around the nucleus in which probability of finding electron with certain energy is maximum. So these 5 definitions as we have seen here. Fire point, okay, that is minimum temperature. That all these definitions are quite confusing, but you have to take care that you write all the definitions in the correct way using the scientific words. Fire point is there, then we have seen the saponification number, then we have seen the ionization energy, that is with the unit kilocalorie per mole. Okay, and then we have seen the electron affinity. Okay, that is just opposite of ionization energy. Also we have seen the orbital concept. So these things are very important. Question 6C, again a very important question, that is just something from the logical point of view. Always ask in some of the interviews also which choice is much better, which choice is not better, that is always asked. Now see, design, what is the question? The first question that was asked here is explain control of corrosion by modification of design and choice of materials. The design of structure should be such that retention of moisture should be as low as possible to control corrosion. Okay, so this is one point that one has to remember. Corrosion can be avoided by using smooth and curved bands, pipe bands. So here they are just asking us to modify the design in order to minimize the corrosion. You have to ensure that your design should be such that the moisture retention rate should be very low. Okay, so that can be done by, you can see here very clearly, riveted joints should be avoided. Welding at L, T and U-shaped places can be avoided to reduce crevice corrosion. Okay, tanks and containers should be designed in such a way that whole liquid should be drained. So what is the meaning of these things? It is something like that. If you are designing something like putting the electrical circuit in some box, meter box is there, its design should be such that water should not accumulate at the top. Otherwise what will happen? There are chances of the short circuit. So it should drain out immediately whenever rainfall comes. So in the tanks also, tank should be designed in such a way that suppose if you are emptying the tank, then what happens? All the water should drain out. Otherwise what will happen? If it will not drain, then the chances of the corrosion will take place. Also the growth of microorganisms will take place. So complete drainage of that particular tanks and containers should be there. So design should be kept such that the corrosion rate can be minimized for that. Welded joints should be used. Okay, but the thing is that crevice corrosion, there are chances of the crevice corrosion. So you have to see that whatever shapes of the welding you are preferring, that is L, T and U shape, that should not be kept in order to minimize the corrosion. Otherwise if the crevice corrosion will happen, then your entire metal or entire particular things will get corroded automatically. So take care, whatever shapes, whatever design you are preferring, it should be such that it should retain the minimum moisture on it, so that the corrosion chances are also minimized. We can